Okay. So this is the first lecture in chapter 4, the work and machines. Work means شغل. شغل. Machines آلات. So in this class we will understand what the meaning of work and how to calculate the work in different cases and what are the machines and why do we need machines and how to calculate the efficiency, الكفاءة, the efficiency of the machine. So starting with work, work said to be done when force is applied on an object and this force causes motion to the object in its direction. So there are two conditions for the work to do work, for the force to do work. First, you need to apply the force to the object. So first, the force must be exerted on the object and it must cause motion to the object. The force must be exerted in the same direction. Okay, or at least it shouldn't be perpendicular. Okay, like if this is the direction of motion, this is the direction of motion of the object, of this object. If the force is in the same direction or if it is inclined by a certain angle, or even if it is opposite, in this case we say the force does work. The force does work. The only case that the force does no work is when the force is perpendicular to the direction of motion. When the force is perpendicular, in this case only we say the force does no work. It exerts no work. لا تبذل شغل. Okay? But other than that, if it is inclined, if it is in the same direction, if it is opposite, it exerts work. Okay? So this young man, he holds the laundry basket and he tries to lift it up. He tries to lift it up. So the direction of force is upward and also the direction of motion is upward. So in this case, we say that his work, or his force, let's say his force exerts work. قوته تبذل شغل. Let's say the other case. This young man holds the laundry basket, so his force direction is upward. This is the direction of force. While he is walking now, he is walking. So the direction of motion is to the right, for example. So force and motion now are perpendicular to each other. Perpendicular to each other. In this case, the force of his hand does no work. لا تبذل شغل. Okay? How to calculate the work done by a force? If somebody, for example, pushes a box with a force F, and his force was able to move the box for a distance d. In this case, the work equals force times distance. So his force times his distance. The work, usually we give it the symbol big W. Big W. So this is the work. So don't get confused between the W of the work and the W of the weight, الوزن. Okay? If we say he has or he applies a force 100 Newton, 100 Newton, and the object or the box moves 5 meters. So what's the work that he applies on the box? He applies 100 Newton and he moved 5 meters. So that's 500 Newton meter, or we can say it's 500 what? Huh? Do you know, guys? Newton meter or
Joule.
Joule. That's
Joule.
right, Joule. So the Newton meter is equivalent to the Joule. So Joule is the unit of energy, and also the unit of, we can consider it as a unit of work. Although in engineering we usually use Newton meter for the work, but also it's working at the joule. Okay. So this is what is the work that we have just determined? What is it? What is it? This is the work exerted by the person, by this person, equals 500 joule. This person exerted 500 joule to the box. But we need to ask ourselves, does all the 500 joule, does it all deliver to the box? Does the box receive all the 500 joule? We need to ask ourselves. If there is no loss, so it's totally received. Okay? Loss like what? Loss like friction. الاحتكاك. If there is friction, that means we have some loss. So let's say we have friction force. And let's say the friction force is 20 Newton. If there is a friction, so we have loss work. شغل مفقود. Okay? So this work loss, we can calculate it. The work lost by the friction. The work lost by friction equals what? Equals the force of the friction times the distance, which is 5. But in this case, because it's low work, so we consider it negative. Okay? Why it's negative? Because friction is a kind of resistance. If the work is done by a resistance, like the friction, so it's considered negative. It's considered negative. So in this case, it's negative 100 joule. Negative 100 joule. So this is the loss or the work loss by friction. So now you or the person exerts 500 joule. But 100 joule of them, 100 joule were lost because of the friction. So what's the leftover? المتبقي. What's the leftover? 400 joules. So this is the work delivered to the box. The work delivered to the box is the 400 joules. Why? Because you exert 500 and you lost 100, so the leftover is 400. Okay? But if there is no friction, let's say there is no friction, so the total work will be given to the box. The total work will be given to the box. One might say, I can calculate the work of the box as follows. I will say, I have two forces, 100 to the right and 20 to the left. So I will say 100 minus 20. Time is the distance, which is 5. It gives you 400 joule. That's totally right. Excellent. Okay. But what I want you to differentiate in between is what? I want you to differentiate between three things. The work done by the person, the work lost by the friction, and the work delivered to the box. You need to know what is this and what is this and what is that. Okay? And what is the relation in between? You understand it, guys? Huh? Do you understand it now? Okay.
دكتور.
Yes.
أرسلت رسالة أنا بالشات. دخلت.
No problem. At the end of the class, we can discuss it. Okay.
Thank you.
Just a small question, doctor.
Go ahead.
If he uses the friction, right? We will put it here. We will do the.
If he what?
If he just give us like the friction in the question.
Okay.
We will do that. We will get the W of box.
Yes, that's right.
Okay. Thank you.
Brakes on a car do 240 kilojoule of work. So the brakes will do 240 kilojoule means 1000 joule. So this is the work done by the brakes of the car, المكابح, to stop the car. During this time, the car travels a distance 40 meter. So the car moves a distance 40 meter while the brakes are being applied. How large is the force of the brakes? We need to know the force of the brakes. You have a car, you apply the brake. This is the force of the brake. The car stops after some time or after some distance. He says the work done is 240,000 joule. So I will say the work done by the brakes equals the force of the brake times the distance. So the work is 240,000. The force of the brake, this is the one he's asking about, times the distance 40 meter. So I will get the force of the brake equals 6,000 Newton. 6,000 Newton. One might say what? Okay, the force of the brake, isn't it a friction? Isn't this one a resistance? Yes, it is resistance. So shouldn't the work be negative? Yes, it should be negative. So the force will be negative 6,000? Yes, the force will be negative 6,000. What does it mean negative? It's opposite to the motion because it's a resistance, because it's kind of friction. Okay? So if you consider it negative, also that's right. Okay?
So, doctor,
Yes.
the work of the friction is always negative.
Yes.
What else?
What else? Any resistance, any force opposite to the motion. Any force opposite to the motion has negative work. Like let's say, for example, you are pushing the box. You are here pushing the box, and maybe let's say your young brother tries to push it against you with a force 10 Newton. Okay, so the work of him, your young brother, the work of your young brother is positive or negative? Huh? It's against you. He's pushing against you. It's negative. So it's negative 10 times 5. So it's negative 50 joule. So this will, that means what? The work delivered to the box now becomes what? Huh? It's now less than 400. It becomes what? 350. 350. Because you lost another 50 joule because of your young brother. Okay? Understand it now? So any
Yes, sir.
resistance is considered negative. Yes.
Sorry for interrupt you, but can you go to the previous slide? The first slide, I mean.
This one?
No.
This one?
ايوه هنا دكتور، انت قلت انه في الحالة الأولى انه ما يبذل جهد إذا كان في عكس اتجاه الحركة. ما تفرق لو كان مثلا اتجاه الحركة
No,
لليمين
no, no. I said if it is perpendicular. No work if it is perpendicular. عمودي.
ايوه اقصد مثلا لو كان يمشي لقدام وينزل ينزل اللي ماسكه لتحت يعتبر عمودي بعد، صح؟
In which picture? This one?
Yes.
What happened if he's doing what?
If it's walk toward and put the basket down.
Okay,
Yes.
that's okay. So his force at this time, it does work.
Okay.
His force does work at this time. Okay. But take care of something, that his force is upward. His force is upward while the motion is downward. Okay. So he applies negative work at this time. But take care of something else. There is another force. There is another force which is the weight of the object. And the weight also does work. In this case, when you put something down, the weight will play a role here. Okay? Because the weight will do some work. Let's see it. We will discuss it now. The work done by incline force. Incline force means the force has an angle. So this father, he pulls the cart of the young girl with a force F. And this force is inclined by an angle theta. So he moved a distance d. So now he does some work. We need to calculate his work. We cannot say that his total force does the work, but only one part of the force did the work. Only one part of the work. One of the force did the work. What is it? The force can be resolved into two parts. We can resolve his force into two parts or two components, مركبتين. What are they? F cosine theta and F times sine theta. We can consider them the horizontal one, Fx, and the vertical one, Fy. And then we need to ask ourselves, where is the motion? The motion is horizontal. Motion is horizontal. So which component caused the motion? The horizontal or the vertical?
Yeah, horizontal.
The horizontal one. So the horizontal one causes the motion. So the work done by the father equals only Fx, only the horizontal component, which is F cosine theta times the distance, d. So in case of inclined force, the work equals F cosine theta times the distance. Why? Because only this component did the work. It caused the motion. What about the other one? Is there any work in the vertical direction? No. So this component did no work. Did no work. Okay? So when the force is perpendicular, to the direction of motion, no work is done. Like in case of what? In case of Fy. Okay? Here in this case, I have a force 1 Newton. I have a force 1 Newton. The force causes motion to the object 1 meter. 1 meter. The distance is 1 meter. Let's assume the force is horizontal, and then I will increase the angle from 0 degree until I reach to 90 degrees, for example. I know that the work done by the force is F cosine theta times d. The force equals 1 Newton, and the distance is 1 meter. So the work done is 1 times cosine theta. Force is 1 Newton, distance is 1 meter. What if the angle equals 0? The angle equals 0. So cosine theta is what? Is 1, which is the maximum. This is the maximum of cosine. So this is the maximum work. The maximum work is corresponding to what? Angle 0. Okay, guys? So when the force has 0 angle, that means this is the maximum work. What if the angle is 90 degrees? What's cosine theta?
0.
Cosine is 0. And this is 0 work, which is the minimum work. What if the angle is 30 degrees?
Is less.
Angle is 30 degrees. Cosine theta is what? Root 3 over 2, which is 0.866. So the work is 0.866 of the maximum work. The maximum work is 1. If we look here, at 0 degrees, the maximum work is 1. At 90 degrees, the work is 0. At 30 degrees here, look, you will find that the work is 0.866. What if we say angle is 45 degrees? Cosine theta is 1 over root 2, which is 0.707. So at 45 degree, this is 45 here, the corresponding is around 0.707. This is the cosine. What if the theta is 60 degrees? 60 degrees.
Half.
Cosine,
Half.
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 Half. So at 60 degrees, you'll find that the work is half the maximum, because the maximum is 1. The maximum is 1. It's now half the maximum. So when you are asked at what angle the work done is half the maximum, the answer is at 60 degrees. Why 60 degrees? 60 degrees because cosine theta at this time is half. Okay, guys? So at 60 degrees, you will get half the work. Let's move to something else. The work done by the gravity. The work done by the gravity. Gravity is the gravitational, which is the weight. And we know that the weight, W, equals mass times gravity. So it does work. If the object moves up or down, the weight does work. Okay. Up or down, it might be directly up or down. It might be moving on an incline, مستوى مائل. It might slide down or slide up. In this case, I have motion up and down. It might slide on this ramp or this hill. It slide down or slide up. Okay. So in all of these cases, we have motion up and down. If the object moves up and down in any of these cases, so the weight does or exerts work. This work equals what? Equals the force times distance. What force? The force is our weight, which is mass times gravity. Time is what distance? Time is the change in height. If you are here and you move here, so you have a change in height equals h. If you are here at A and you move to B, you have a change in height equals h. If you slide down, you have a change in height equals h. In all of these cases, the work done by the gravity equals the force times the height, which is mgh. mgh. So if you are asked in any case, any of the three cases or any other case, what is the work done by the gravity? You will say the weight times the height, which is m times g times h. Okay, guys, this is called the work done by
Can
the
you
gravity.
explain it again, please, Professor?
The work done by gravity. By gravity here, I mean the weight of the object. The weight of the object. Okay. Let's take it the first example here. The direction of weight is what? W equals mg downward. Let's say the object falls down. It was at a certain height and then it moves to another height. The distance here is what? What is the distance? Distance is the height. The distance is the height.
Yes.
Okay. So what is the work done by the force? The force times the distance. So it's W, the work done by the gravity equals weight times height. This is weight. The small w is weight. Okay. Weight times height. And I know that weight is what? Mass times gravity. So it's mgh. mgh.
Okay.
Okay. This is also valid for any case. For any case, like it's a little bit hard, but let me describe it to you. In the incline, I have the weight downward, and the object slides down a distance d. Okay. Let's say this is angle theta. So usually in this case, by the way, if you don't understand this part, it's not very important. But if you understand it, it's good. I will resolve the force here. I will resolve it into two components. This angle equals this angle. And we can discuss it later if you don't understand why. So this is W cosine theta, and this is W sine theta. So which part causes the motion? W cosine theta. So the work done equals W sine theta times the distance d. Okay? Okay, let's look to something else. Let's forget the weight and forget all the resolution, and let's look at the distance d and the height h. What is the relation? H equals what? Or d equals what?
The difference in the height.
H equals d sine theta. This is right angle triangle. This is right angle triangle. So h, the height h, equals d sine theta. Or we can say d equals h over sine theta. It's the same. So I will remove this d from here and write it h over sine theta. So this sine theta goes with this sine theta. The leftover is what? The weight, W, times h, which is mgh. Anyway, if you understand it, that's good. If you don't understand it, like, let's know it, mgh, and inshallah, next year when you study physics 101, we will study it again, okay? So again, the work done by the gravity is mgh. Let's discuss this problem. A worker slides 60 kilogram crate up the inclined ramp. There is some worker. He tries to push this up the ramp. By what? By applying a force. By applying this force. This force is how much? 400 Newton. So this guy will push the box, and he will move with the box. He will move with the box. Okay? He will push the box until he reach to the top of this platform. Okay? So he applies a 400 Newton, force parallel to the ramp. Parallel to means what? What the meaning of parallel? موازي, parallel. Okay? So again, let's read it from the problem itself. A worker slides a 60 kilogram crate up the inclined ramp that is attached to a platform 1 meter above the floor. So it's 1 meter above the floor. This is the height of the ramp. Okay? As shown in the figure below. He needs what? He needs a force. So he will apply 400 Newton force parallel to the ramp. Parallel to the ramp. This is the force needed to slide the crate up the ramp at constant speed. This is like he needs to say this is the minimum force needed to move the ramp, to move the box up the ramp. Assume the friction is negligible. That means no friction. Assume no friction. Okay? Friction is negligible. What is the length of the ramp? Find the length of this ramp. Let's try to discuss this problem. First, I will look at the person. This person. He does what? He pushes the box to move it from down the ramp up the ramp here. Okay? So he applies a force 400 Newton. So what is the work that he does? He applies a force 400 Newton parallel to the ramp. He pushes with this force until he reaches up the ramp. So what is the work that he exerts? The work done by the worker equals what? Can anybody answer me? He has force 400 Newton and he moves a distance L.
Yes.
No, I'm not talking about the box. I'm talking about a person. This person applies a force 400 Newton. And he moves a distance L. So what is the work of the person?
24,000.
The force multiplied by L.
That's right, the force multiplied time the distance. So it's his force times his distance. Okay. The force here is what? 400 Newton. The distance is what? He will move down from here until he reaches up here. So he will move a distance L. So this is what? This is the work done by the person. The work exerted by the person. Now let's forget it. Let's look now at the box. The box at the beginning was down here. It was down here. And it will move up to the top of the platform. So it moves against the gravity here. So there is the weight. What is the work done by the gravity here? The work done by the gravity. So the work done by the gravity equals what? Equals the weight times the height, which is, we just say it, mgh. mgh. M is 60, g is 9.8, and h is 1. That gives you what, guys? 588 joule. So actually, the 588 joule is what? This is the work, or the minimum work needed to lift this object up the platform. So this is the minimum work needed to lift the object up the platform. Now we need to ask ourselves a question. The person, he exerts work, and the box receives work. Are they equal or not? Because we know that the person might exert some work and there might be some loss. There might be some loss. فقد.
Either
And the
equal or
leftover is received by the box. So is there any loss here? No, there is no loss. There is no loss. Okay. Why there is no loss? Because friction is negligible. In our case here, friction is negligible. Okay. So that's a kind of approximation. So we can say the work done by the person equals the work received by the box, because there is no loss. In this case, I will say 400L equals 588, and L will be 1.47 meter. You understand it? Let's change the problem.
Sure.
Now we got the answer, but let's change the problem. What if the friction is not negligible? What if he says the friction is 20 Newton? What are you going to do?
We are going
What are you-
to نطرح
You
أول
need
شيء
to calculate the work done by the friction. The work done by the friction equals what? The 20 times what?
L.
Times L. Excellent. Times L, because friction is against the motion. So it's
Yes.
20 times L. So you have the work done by the person minus the work lost by friction. And why minus? Because friction does negative work, so it's minus here. So some people can consider it minus while they calculate the friction, or they can add the minus as I did now. Minus the work that is lost by the friction, the leftover is given to the box. The leftover is the work given to the box. So the work by the person, 400L, minus the work by the friction, 20L, gives you the work delivered to the box, which is the 588, and you can calculate L in this case. Okay? Okay, guys? You understand it? If we have friction or if we don't have friction? Okay, good. The second part is machines. Machine. What is the machine? Machine آلة. آلة. What is it? It's a device. Why do we need machine? To make our life easy. Okay. To do the work in easy way. How is that? The machine does what? The machine might increase your speed. Machine might increase your speed. Like when you ride the bicycle. When you ride the bicycle, it increases your speed. It might increase the force. We will know how it will increase the force. Or it will change direction. Change direction like this pulley, for example. I will pull the rope. I will pull the rope so I can lift this weight. I can lift it up. Okay? So the machine might increase speed, increase force, change direction to do the work easier. But the machine can never increase work. Never. Impossible for the machine to increase work. Because machine, you apply some kind of work on the machine. So the machine is not going to produce work. As you remember, the principle of energy. Energy cannot be produced from nothing. It's just converted from one form to the other. مبدأ الطاقة. Okay. So the work is, you just convert the work from one place to the other, or move it from one place to the other, but you cannot produce work from nothing. You also cannot produce energy from nothing. You just change the form of the work, or the form of the energy. Okay. There are two kinds. So again, you need to remember this thing. You need to remember this statement. This is the most important statement. You cannot increase work. You can increase force, but you cannot increase the work. Okay. If your machine is the best machine ever, if it is the best ideal machine, the best scenario is you can give the machine some work. We call it input work, and the machine will deliver you the same amount of work, or an equivalent amount of energy. Okay, this is if the machine is the best ever, and there is no machine that can give you the exact or the same work or the same amount of energy in the real life. In our real life, there is no machine that can do that. Why? Because usually machines, they lose energy, they lose work. They lose it because of what? Usually because of heat, because of friction. All of these are losses. Okay. So if you apply work, let's say 100 joule on the machine, usually what you get from the side, the result will not be 100 joule. It will be 90 joule, 80 joule, 50 joule. Okay. But you will not get 100 joule unless we are talking about ideal machine. Okay. And the ideal scenario is not exist in our real life. So in our real life, there is no ideal machine. But in the problems, in some problems, we can consider ideal machine. Okay. Anyway, so we can divide the machine into simple machines, آلات بسيطة, and the simple machine is a machine that does the work with only one movement, only one simple movement. The work is done. Like lever, you push here, it lifts the weight or something the other side. Pulley, you might pull the rope so it lifts the object. Okay. Inclined plane, the same like the one we have just discussed. The wheel, okay. The screw, the wedge. Okay. All of these are simple machines. Yeah, ideal means مثالي. The word ideal means مثالي. Okay. The other one is called the compound machine. Compound مركبة, آلة مركبة. What is the compound machine? it's a compound machine is a combination of what? Two or more simple machines. Two or more. Like here in the scissor, I have a lever, another lever. Lever means ذراع. Lever, ذراع. I have two levers, and between of them there is a pin. So I consider it a compound machine. Of course, it's simple compound. It's not very complex, but still it's compound. The bicycle is compound because it has wheels, it has gears, it has chain belt, it has many parts. Okay, so it's compound machine. Car, very complex. Okay, so the machines might increase the speeds, like wheel or bicycle, might change direction, like the lever, or like the axe here. Axe is this axe is a wedge. We call it wedge. Okay. Wedge, like this one, wedge. Okay, you apply a force downward, so it pushes the two pieces of the wood away from each other. Okay, so you might use it to change direction. Increase force, like the nutcracker. This nutcracker كسرت الخانق ولا اللوز ولا whatever you call it. Okay, the jack, this jack, you apply some force here, so you can lift the car. So with small force, you can lift the car, which needs a huge amount of force. Okay, so the machine can increase the force, but again, it will not increase the work. Okay, a simple lever or a simple machine like this lever can increase the force. For example, if this is the pin, or sometimes we call it the fulcrum. Okay, this machine increases the force. You apply a force here, F. So you can lift this load, W. What's the relation? The relation is the momentum of the first the moment of the first one equals the moment of the second one. Moment means عزم. Have you the moment? عزم. Okay.
Torque.
The moment,
Torque, right?
or the torque. Some in physics we call it torque. In engineering we call it moment. That's right.
Oh, okay.
In physics they call it torque.
Yeah.
In civil engineering usually they call it moment. Okay, but physics, electric engineering, mechanical engineering, if you are talking about engines or motors, usually we use torque. Okay, but if you are talking about some buildings, some levers, we call it moment. But the same issue actually. So the moment here, moment is force times distance. Here the distance I will call it d1, and the other side distance I will call it d2. So W times d2. So this is the balance of the moment. What if d is very short and d1 is long? So according to the balance, you will need small force F to lift a big load W. You will need small force F to lift a big load W, because there is a difference. D2 is small and D1 is long or big, so the force will be small while W will be very big. Okay, so this is an example for a simple machine. Yes, Hamoud, go ahead.
دكتور ليه FD? It's
The moment is force times distance. The moment is force, like you will study it in engineering courses, maybe. The moment is called force times distance. This is called the moment, or the torque, Okay, this is the definition of the torque or moment.
Doctor,
Yes.
why in the second part you wrote W times distance?
Because
Why
W is
W then?
the weight of the object, the weight of this object. This is the weight. Weight. Okay, this is the weight, not the work. Weight. Okay. So this is an advantage. This is a big advantage that the machine can increase the force. But what about the work? What about the work? Let's look at the work. You said the work cannot be increased. The work cannot be increased. That's right. So this lever, for the force to lift the load, look at this distance L, and this distance on the other side H. Which one is bigger? Or which one is longer? From the geometry of the shape, L is much longer than H. H is much longer. So the work done here, this is the work done by the effort of the person is F times L. While the work done on the other side, we have weight, W minus W times H. So the work done here is force times L. The work done on the other side is W, the weight. This is weight, not the work. This is weight times H. Okay? We said the weight is very big and the F is very small. But on the other side, the L is very long and the H is very small. Okay? So the work done here and the work on the other side, this one we call it the input work. Input work. This is big W, work. And this one we call it the output work. The best scenario ever when this is the ideal lever, مثالية, ideal lever, the input work equals the output work. The input work equals the output work. This is if it is ideal. So in this case, if it is ideal, F times L equals the weight times H. Okay, the input work equals the output work. But usually that doesn't happen. Usually this doesn't happen because there are some losses. There are friction. Okay, so output work, the real life cannot be greater than the input work, but usually it's lower than the input work. So we need to define the efficiency, الكفاءة. What is the efficiency? Efficiency is the ratio between the output work and the input work. Okay, and it's measured in percentage. That's why we divide the output work over the input work times 100. Okay, it gives you the efficiency as percentage. So if you have a certain machine, or machine, we don't care. If you give it input work 100 joule and you get output work 80 joule, what is the efficiency of this machine? The efficiency
80%.
is 80 divided by 100 times 100 gives you 80%. What does it mean? It means you will lose 20%. You will lose 20%. There is loss of 20%. Loss as what? This loss, friction, heat, or any kind of loss. Okay. So the ideal machine, as I said, it's 100%, which we cannot find in our real life. So in the problem, you need to if he say that there is an efficiency, okay, that means that's not an ideal machine. That's not an ideal machine. And there is a relation between the output work and the input work. Okay. The last part is the mechanical advantage. Mechanical advantage is the relation or the ratio between the output force, not work, output force and input force. It's the output force divided by input force. Like let's say if in the liver, the liver that we have just discussed, there was a big weight. Let's say that weight is 200 Newton, and you need a force 50 Newton to lift it up. You need 50 Newton to lift, ترفع, to lift the 200 Newton. So what's the mechanical advantage of this lever? The mechanical advantage equals the output force over the input force. What is the input force? It is the force you apply. This is called the input force. And what is the output force? Output force is the result. What do you need? I need to lift a weight. So this is the output force. So I will divide the output force over the input force, gives you 4. 4 what? 4 times. 4 times. 4 مرات. So this machine increases the force 4 times. But again, the work will not increase. The work will not increase. Okay? Do you understand this relation, guys? You might increase force, but you will not be able to increase work. But usually the work decreases because of the loss. Let's solve this one. Which of the following is a compound machine? Bicycle, or wedge, or pulley, or screw, or inclined plane. All of these are simple machines, except the bicycle, it's compound machine. Which of the following cannot be done by a machine? Can the machine increase force? Yes. Can the machine change direction of force? Yes. Can the machine increase the speed? Yes. But can the machine increase work? Never. So the machine cannot increase work. Let's try to solve this one. A student exerts a force 250 on a lever, 250 Newton on a lever, through a distance 1.6 meter as he lifts a 150 kilogram crate. This is a mass of 150 kilogram. So the weight equals what? 150 times 9.8. The efficiency is 90%. 90%. How far is the crate lifted? So when he lifts it, he will lift it a certain distance h. But this guy, he did a distance what? 1.6 meter. What should we do? What should we do? Here is the input work, and here is the output work, and the efficiency is 90%. What is the input work? The force that he does times the distance he moves. And what is the output work? The weight, this weight, or we can say it's mgh, very easy. I need to lift the weight upward, so that it's mgh. mg is the weight, 150 times 9.8 times the height h. What is the relation between both? Efficiency equals the output work over the input work, this is work, times 100. So I will say 90%. I can take the 100 to the other side. So 90 over 100 equals the output work divided by the input work. Very easy, you can solve it to find h. So the h will be 0.245 meter.
Doctor,
Again? Again?
no.
Yes, yes, please.
Again, I will take only 1 minute, Rasim. I know that you need to leave. Only 1 minute. Let me repeat it again, and then you can ask. A student exerts a force 250 Newton on a lever through a distance 1.6. So this student, he applies a force down. He applies a force down. Okay? This force is 200 Newton, and he moves a distance 1.6 meter. Okay, so he does work or he exerts work. His work is his force is his distance. You understand this point? Huh? Understand this one? Okay. What will happen? The machine does what? The machine does what? The machine, he does this to lift 150 kilogram crate. There is a crate. This crate has a mass. Its mass is 150 kilogram. So its weight is 150 times 9.8. But here there is an efficiency, كفاءة, 90%. Like when you apply 100 joule, you will receive it 90 joule only, because there is an efficiency 90%. Okay, so if he applies whatever work, he will receive only 90% on the other side. What is the work on the other side? The output work here is what? There is a mass, and you lift this mass up. So the work done on the mass, or the work done on the box, is mgh. The work done on the box to lift it up is mgh. mgh, which is the work done, as we discussed it, the work done by the gravity. Mass is 190, g is 9.8, h we don't know. We need to find this h. So this is the output work. Now we know the input work and the output work. The efficiency, 90%. So 90% is the output work over the input work times 100. This is the equation of efficiency. I took the 100 to the denominator on the other side. It becomes 90 over 100. Equals what? The output work. The work out. Divided by the input work. The work that the student does. Okay? Then I solved this equation to find the h. That's what I did. Okay? So
Okay. Thank you very much.
if you have a question, you can ask. If you don't have